So can everyone hear me? Okay, so thank you for having me today at the workshop. So I do have two talks back to back. So the first of which is Asylo's Unified Enclave Identity Framework. So,
You have to speak up.
okay. So the first talk is Asylo's Unified Enclave Identity Framework. And so I am a software engineer at Google, and I work on Asylo, specifically focusing on the identity and attestation part of our framework. So let's jump right in. So first off, what is Asylo for anyone that doesn't know? So Asylo is an open source framework for writing enclave applications. It was open sourced a little over a year ago in May of 2018, and development is still ongoing today. So much of the development on Asylo is focused around creating a richer development environment and allowing developers to leverage the hardware capabilities of enclaves, all while keeping the overall framework technology agnostic. So this is actually one of the greatest challenges behind writing a general purpose enclave SDK. So the current industry landscape contains many interesting and uniquely different technologies, and the goal with Asylo is to reconcile the differences between them and to present them to developers under a uniform programming model. So we believe that this is essential for being able to build large-scale systems that are composed of many different enclave technologies. So today, Asylo supports Intel SGX and a simulated enclave backend, but we look to support other technologies in the future as well as they mature. So enclave identity is one very critical aspect of working with enclave technologies. So how do we provide a unified programming model within our identity framework? So Asylo's identity framework provides abstractions around several key building blocks. So we have assertion, which is a cryptographically verifiable statement that asserts an identity. Identity, which encapsulates the security relevant properties of an enclave and of its execution environment. And identity expectation, which is a way to set an expectation on some other entity's identity. And basically, this is used to define ACLs. So these three core notions are defined in Asylo using protocol buffer data definitions. They can be expanded to support specific types of assertions, identities, and identity expectations by nesting the more specialized structure into the generic one. So this is how Asylo defines, for example, SGX-related definitions. So for assertion, we have multiple ways of asserting an SGX identity. So we can have a SGX hardware report from the CPU, which is a local assertion, or a remotely verifiable SGX quote from a quoting enclave, which is a remote assertion. So for either assertion type, we can extract the properties of the SGX enclave's code identity and the properties of its execution environment to create an identity. So for identity expectation, there are many different possibilities. So for example, we can have an expectation on the code signer or on the code hash. So of course, these are just two examples. We can define fairly complex expectations for identities that have many properties like SGX code identities do. So Asylo actually provides users with both options. The most common expectation types that we expect users to use, as well as the ability to craft a highly specific expectation. So these core building blocks are the foundation for Asylo's identity framework. Asylo also defines a set of core interfaces that operate on these abstract data types. So these are assertion generators, assertion verifiers, identity expectation matchers, and secret sealers. So each of these interfaces is implemented for different enclave technologies. For backends like SGX that have both local and remote attestation mechanisms, we actually provide multiple implementations of assertion generator and assertion verifier. So with these core building blocks and interfaces, Asylo provides a unified identity framework that can be used to build higher-level identity protocols and identity systems. So one of the major applications of our identity framework is secure attested channel establishment. So another is secret sealing with enclave identity-based ACLs. So I will be focusing on secure channel establishment for the remainder of the talk. So gRPC is the most convenient communication mechanism available for Asylo applications. So gRPC is fully supported inside Asylo applications because of the rich POSIX runtime environment that is provided by our Enclave runtime libraries. So gRPC channels in Asylo are secured using a custom transport security stack. In this stack, channel establishment is done using a key negotiation protocol that handles Enclave attestation. In this communication model, the gRPC endpoint is placed inside the Enclave so that the channel is established and terminated within the Enclave's protections. So Asylo also provides developers with the tools to create and enforce authorization policies based on Enclave identity expectation. And this allows developers to access control sensitive RPCs in their Asylo Enclave. So Enclave Secure gRPC is a fundamental building block for large-scale distributed systems of enclaves. So we imagine a world in which systems are composed of not one, but actually many different enclave technologies. So these systems would become impossibly complex if we use different one-off security protocols between every two different endpoints. Providing a unified approach to attestation, authentication, and authorization is essential for developers to be able to reason about, design, and ultimately to implement these types of large-scale systems. So how exactly does Asylo provide a unified approach to channel establishment between enclaves? Well, we use Asylo's notion of assertion generator, and assertion verifier to define and implement a generic authentication protocol that supports various mechanisms of attestation. So this is exactly Asylo's Enclave Key Exchange Protocol, or ECAP. So ECAP is an elliptic curve Diffie-Hellman authenticated key negotiation protocol that is used for forming secure channels. So this protocol is based on the application layer transport security, or ALTS handshake protocol that was developed by Google for securing RPC communication systems. So ECAP is a 6-step variant on the ALTS handshake, and it has several distinct properties that make it useful for enclave systems. So first, ECAP allows participants to authenticate with arbitrary enclave identities. So before authentication takes place, participants first negotiate which assertions they will exchange. And this negotiation happens in the client pre-commit and server pre-commit steps. The participants later exchange the negotiated assertions in the client ID and server ID steps. So again, these assertions could be assertions for any kind of identity at all. So since ECAP can be used with arbitrary enclave assertions, it is possible to use ECAP-based channel establishment between applications running in different enclave backends. So this is a really unique and useful property. ECAP also allows participants to assert multiple identities. So this property can be useful in scenarios where there are multiple identity systems in play. So for example, an entity may want to present both an assertion of its code identity as well as a certificate for some key that it wields. So ECAP enables exactly these kinds of scenarios. ECAP reconciles the differences in attestation between various enclave technologies and provides us with a common method of channel establishment between enclaves. This is possible because ECAP is built on top of Asylo's identity framework, which provides the appropriate abstractions to generalize attestation across different enclave technologies. Secure channel establishment is one very powerful application of Asylo's identity framework. There are, of course, other ways to leverage this framework as well. So one use that I mentioned earlier in the talk is secret sealing with enclave identity-based ACLs. So the Asylo team aims to support other enclave backends in the future as well, so that these kinds of applications can have broader use and broader impact. So we do invite the community to help us in this effort. So please connect with us on our mailing lists and check out asylo.dev as well as our GitHub to learn more about Asylo. Thank you. And so I will probably just jump into the next talk and hold questions to the end so I don't